Hello lovely viewers, welcome back to Pamo12 official YouTube channel. Today we are going to look at some identities in algebraic expression. So we are going to talk about identities in algebra. And in these identities, what we are going to look at first is differences of two squares. When I talk of a difference of two squares, what does it mean? You look at it. Now, a typical example of a difference of two squared is what I have over here. So, suppose x and y are numbers in a squared form. The differences between the x and y is what we call the difference of two square values. And how to simplify difference of two squares, we will look at it. The next thing we are going to look at is a perfect square. When we talk of a perfect square is a result of any number which is multiplied by itself. So for example, when I multiply a number, say 3 by itself, which is 3, the result I am getting here is a perfect square number. So some examples of perfect square numbers are 1, 4, 9, 10, 25, and etc. So we will look at how to expand a perfect square in algebra. So a typical example of a perfect square is x plus y all squared. Here x plus y is acting as expression to any number at all. So it can be 9 to the power here, because we are dealing with algebra, we are taking x plus y as an expression or a term with a power of. So that is a perfect square. And then the next one, now a perfect square can be positive or a negative. So what we had earlier was x plus y all to the power squared. What if I have x minus y all to the power squared? Now this x minus 1 all to the power squared is different from the first property we talked about, which is x squared minus y squared. X squared minus y squared is an expression x to the power 2 minus expression y to the power 2, expression x minus expression y all to the power 2. So x minus 1 all to the power 2 is a perfect square, whilst x squared minus y squared is a difference of two numbers which are squared. Then we also look at binomial expansion, and binomial expansion we have looked at how it is being simplified in our previous videos. So on this note, if you have not subscribed to my channel, kindly do that so that you get access to the videos I have uploaded earlier, for you to get more concepts or more light on what I am to do today. So without wasting much time, let us look at how we can simplify a perfect square, or we can simplify a difference of two squares. In actual terms, how do we expand them and how do we apply them in questions? So let us go to our board. Now, when I have 3x, or say I have 3 squared minus 4 squared. Now this is said to be a difference of two squared values. Why are we saying so? Now 3 here has an exponent of 2, which we normally say a squared. 4 here has an exponent of 2, which is squared. Right? Anytime we talk of differences in mathematics, then we are talking about a subtraction. So what we use to find the difference between numbers is a subtraction sign. So 3 squared minus 4 squared. 3 being a squared value, 4 being a squared value, the differences between this squared value and this squared value is what we are talking about. So how do we simplify such expression? Now in simplifying expression like this, it's quite simple. Let's see. You open a bracket, then the first number or any value that appears first is written. So you are going to write 3, then you bring an addition sign. Then the next number or the next value, which is 4, will be also written here. Then you close the bracket. Then you open another bracket without any addition sign. Okay, so we open the bracket again. Then we repeat these two numbers. But this time we write in between those numbers a negative sign. So we are going to have 3 minus 4. Right. Now, because I used numbers, I can easily simplify this bracket and then simplify this bracket. Then I can multiply them and get my answer with ease. What if I have a letters? Then it would have been quite difficult for me to express them in their simplest form. So this is going to give me 7. We can decide to bring the bracket if we don't want to bring the bracket, we are going to introduce a multiplication sign, because we know brackets means multiplication. So this bracket and this bracket without any sign in between them means that they are multiplying. So I'm going to have 7 multiplying, then 3 minus 4 is going to give me -1. I have explained why it is -1 in our previous videos. So follow this channel and then get more idea or more understanding to this particular question. So 7 multiplying -1, to have explained it in our previous video. So kindly follow this channel and then get access to the videos I am talking about. So 7 multiplying -1 is going to give me a -7 as my answer. Alright, so this is the solution to this particular figure. Now I've used numbers. Now let us look at in algebraic state. So assuming I have x squared minus y squared, x squared minus y squared. Now we can simplify this by applying the same method we used in the first example, which we used numbers. So in place of 3, I have x. In place of 4, now I have y. So what do? We will write, or we will open a bracket, then write our first letter, which is x. Then I'll bring an addition sign. Then I will introduce my next letter, which is y. Then I'll close the bracket. Then I'll open another bracket with the expression x minus y. Alright, so with this expression, there is nothing we can do to it. So we have expanded this particular expression. So anytime you are having any difference of 2 squared and you are asked to expand, this is how we go about it. Now let us look at, we know numbers which are a perfect squared number. Okay, so if I have, say, 9x squared minus 4y squared. Alright, so now let us look at, we are still in the under the difference of 2 squared. We've not moved from where what we are looking at. Now, if I have 9x squared minus 4y squared, in the first example, there was no coefficient to x and y. In actual sense, there was a coefficient of 1 which we don't write. Now, looking at the x and y here, there are numbers attached to them, that is their coefficient. So before we can simplify this using the difference of 2 squared, we need to look at the coefficient of each number beside the variable. If those numbers can be expressed as a perfect square, then we go ahead. If it cannot be expressed as a perfect square, then we also know how to do that. So looking at 9, 9 is a perfect square of number 3. That is, when I multiply 3 by 3, I'm going to get 9. So I can express 9 as 3 times 3, which can be expressed in an index form of 3 squared. Same thing applies to 4, which can also be expressed as well, 2 squared. So on this note, I can write these two expressions as 3 squared, then x squared. Then I'll bring my minus sign. In place of 4y squared, I can write this as 2 squared, then y squared. Okay, so now I am able to express 9 and 4 as a perfect, or as their indexes. Because they are a perfect square numbers, it's quite easy to express them as an index form. Okay, so here I have a squared and a squared. There is one property of indices, which says that if I have a exponent m times b exponent n, then I can write this whole thing as a bracket open they have the same exponent. Let me correct myself here. So a exponent m and then b exponent m. Okay, then I can write this as a b all exponent m. Okay, so we can write these two things as one term with a common exponent. So a times b in a bracket all exponent m. So let us use this same thing into what we are doing over here. So it means that I can write this as what? Bracket open 3x squared then minus 2y all squared. Very, very simple. So now this looks like a difference of 2 squared. So now in place of x, I now have it as 3x all squared. And in place of I have it as what? 2y all squared. So we proceed with how we expand a difference of 2 squared. So what do? We say you open a bracket, then the first term here, the term here is 3x. So I'm going to write 3x, then plus 2y. Then I'll close my bracket and open another bracket. And I'm going to repeat the same thing, but this time bring a negative sign between them. So 3x minus 2y. Okay, so this is how we expand this particular expression. It's very, very simple. Let's take our last example under this, and then we move on to the perfect squared value or the perfect square identity. So if I have a 16a squared minus 25b squared. 16a squared minus 25b squared. So these two, we will look at the coefficient of each variable and see to it that if they are perfect squares. Now, if they are perfect square, then we can express it as an index of square. So 16 can be expressed as 4 times 4. So it means that I can write 16 as 4 squared. So 4 squared. Then come here with my a squared. Now I'll bring my minus sign here. 25 can be expressed as 5 times 5, which means that 25 can be written as 5 squared. And then I'll bring my b squared here. So with this, let us look at what we are going to do to this. Now the concept we did earlier under the indices rule. I can write this as 4a or in a bracket. Then I'll bring my squared minus 5b or in a bracket squared. Okay, so this is looking like x over here. So the whole expression, if you are to compare this to x minus y or x squared minus y, 4a is now acting as x and then 5b is acting as y. So we can write this as 4a minus 5b in an expression or in a bracket. Now open another bracket. 4a plus 5b. Okay, someone will ask, why did I bring the minus here before the plus here? Yeah, it's not compulsory to be bringing the positive first before the negative. Someone can decide to bring it as 4a minus 5b, 4a plus 5b. But what we cannot do is bringing the 5 before the 4. In addition, it's quite acceptable because additions are commutative. So if I bring the 5a minus plus 4b, it's quite accepted. But I cannot write 5a minus 4b or 5b minus 4a. So we can decide to bring 4a minus 5b before the 4a plus 5b. It's accepted. Okay, so I would want you to try this under the difference of 2 squared for me, and then you present your solutions at the comment section, and then I will tend to your solutions. If you also want me to help you in other lessons or other topics too, I will just write everything under the comment section, then I will reply your messages and then we will take it from there. So let's continue. Let's go with this question. And if I have x squared minus 81y squared, so you try this for me and then you present your solution at the comment section. Now let us look at the other identity, which we say is a perfect square. Now what is a perfect square? I explained it earlier. So let's take example. If I have a, or if I have a plus b all squared. Now this is also known as the binomial expansion. So a binomial expansion and a perfect square are quite the same, but perfect square is normally an aspect of a binomial expansion. It is normally a number multiplying itself. Okay, but multiplication of two different numbers can be a binomial expansion, two numbers multiplying each other. Binomial means what? Two numbers or two numerals. Okay, so in simplifying this, I can write this as a plus b, then multiplying another a plus b. Okay, so in case you have no idea about what we are doing here, let us look at, if I have 3 squared, 3 squared can be expressed as 3 times 3. And this 3 times 3 can also be expressed as bracket open 3, another bracket open 3. Right. So we are using the same idea here to expand what we have over here. So a plus b all squared. So I said we expand this by in a bracket a plus b, bracket open again, a plus b. Now this one looks like the algebraic expansion we did earlier. So what did we say? We said the first number in this bracket will multiply everything in the whole bracket with the second expression, and the second term in the first bracket will also multiply everything in the second bracket. So it means if I have this, I'm going to have a multiplying a plus b. I close the bracket, then I'll pick the next term, which is positive b, so plus b. Now open my bracket, a plus b. Then this is like the multiplication of algebra that we did in our previous videos. So let's see. So the first term will multiply everything. So a times a will give us, I'm going to have a squared. Then I'll bring my positive sign here. A times b will give me ab. Then I am done with expanding of this bracket. I'll come to the next bracket. Before that, there is a positive sign here. So plus a times b will give me what? ab. Then b times b will give me b squared. Right, so after we are done with this, the next thing for us to do is to look through the expansion and see whether they are like terms. Like terms has been explained in our previous videos. So we could see that a, b, and ab here are like. So it means this has a coefficient of 1, this has a coefficient of 1. So I will add their coefficients, making 2. So I'm going to have a squared plus 2ab, then plus b squared. Right, so that is the whole expansion to this particular question. So it means if you are given any question in a perfect squared form and you are asked to expand it, now simply this is how it is being expanded. It's very, very simple. Let's take another question and see. So I have, say, so 2a, this I want to take negative. So you can see how it is being expanded if it is not positive. So 2a plus or minus, let's say 3b. Okay, so 2a minus 3b all squared. Okay, so this is the same thing as we did to the first question. So this one is like 2a minus 3b multiplying the same 2a minus 3b. So I can write this as bracket open 2a minus 3b. And then I open another bracket. Then I'll repeat the same thing. 2a minus 3b. I'll close the brackets. Then we follow the same process. So 2a will come out. That is 2a in the first bracket. So 2a. Now open a bracket and then multiply it by all the terms in the second bracket. So 2a minus 3b. So the next term in the first bracket is negative 3b. Then have 2a minus 3b. Okay, so let us continue from the top here. So from here, 2 times 2 will give me 4. We've done this in our previous video. So, and if you want to get more understanding to what we are doing here, you follow this channel, subscribe, and then like, and then follow the videos we have over there. So we multiply the coefficients. So it's 2 multiplying 2 giving us 4. So 4, then a times 2 will give us a squared. Then 2 plus, or that is positive 2 multiplying negative 3 will still give us negative. Right, so better understanding this, go to the videos we have over there in the previous videos and then you follow. So we have minus 2 times 3 will give us 6. So 6ab. Alright, so here to negative and positive will give us negative. So negative 3 times positive 2 will give us negative 6ab. Then negative 3 times negative 3, the negative multiplying negative will give us a positive answer. So plus 9. Then b multiplying b will give us what? B squared. So after we are done here, we look at it whether there are like terms in it. If there is no like terms, then we leave it as it is. But if there are like terms found here, we expand it using, or we add or subtract the like terms involved. So here 6ab and 6, that is negative 6ab, negative 6ab are like terms here. So you add their coefficient. If it demands to be subtracted, we subtract the coefficient. So before that, we will repeat or we will write our 4a squared, which is already there. So 4a squared. Then minus 6 will give us negative 12. So minus 12ab. Then plus the 9b squared over here. Plus 9b squared. And that is the solution to this particular question. I believe these tutorials has really have an impact in you, right? So if there is anything you don't understand, please don't hesitate to link me the comment section and I will gladly reply you and then throw more light on whatever you are bothered with. The other things or the other part of the identities, we've treated them in our previous video. So you just follow this channel and then go to our channel and then follow the videos or watch the videos we have over there, and then you get the concept of. Now we will look at our next topic in our next videos, which is factorization. But before that, we will come to you with more questions, especially an application questions to algebra. With whatever we have learned so far, we will consider some questions and then solve them so that we understand whatever we are doing. It's not going to be like we are just teaching you how to solve questions related to questions like this. So we will take our time and then come with questions and then solve them. Then make sure that you also understand and to contribute. If you also have a question that you are bothered with related to this topic, just write it at the comment section and then I'll do a tutorials on that based on the questions you have sent to me, and I'll give the solutions, either a one-on-one or I'll teach you on the tutorial so that you can also watch and then understand it. Alright, so on this note, goodbye to you all.